and welcome to today's session. And you know, now the Agentic AI has emerged as one of the most exciting topic in today's Gen AI landscape. So as a forward-thinking developers, I know you are looking to go beyond just understanding the theories or concepts or terminologies. So you want to see the real scenarios or real innovations in actions, and then how to maybe you want to build your own AI agents applications from ground up. So that's exactly what we are here to deliver today. I'm Haowen Huang, a senior developer advocate at AWS based in Hong Kong. And I'm honored to join my colleague Jackie Wu, who is senior solution architect also from Hong Kong. Yeah, Jackie's here.
Thanks for joining the session. Hope you enjoy it.
So today we will take you through how to build agentic AI on AWS. In practice, using Amazon Nova Act and Strands agents. So we will bring you a lot of demonstrations. From my side, I will put two hands-on demonstrations of AI agents. Yes, one is interactive weather information agent, and the other is educational video creation agent. And Jackie will bring more multi-agent. He will use in some financial scenarios later. And here is the agenda for today. First, we will start with some fundamental, like to explore how AI agents concept to ensure we are all on the same page. Then, next, I will provide a hands-on demonstration showing you how to build a real agent application for Hong Kong weather information using MCP and the Amazon Nova Act. Then we will dive into a real-world applications by exploring how to build enterprise agentic AI solutions from the ground up using open source Strands agents. You know, open source Strands agent is AWS recently open contribution to the open source communities. Following up, Jackie will bring some valuable experience from the capital markets. He will introduce you to 4 multi-agent collaboration patterns and tools with open source Strands agents SDK. And he will also demonstrate these concepts through 2 practical financial use cases. And finally, we will ramp up and with a comprehensive overview of AWS complete agentic AI portfolio. Let's begin by examining the future trend of the agentic AI first. So if we dive deep into the evolution of generative AI, you will see that it has followed a clear progressions. So which each phase bring a new priorities and challenges for business. So on the left, you see the low agency and the more human oversight, and which are rule-based and require high human oversight. So on the right, we see high agency systems and can operate independently and even make some strategic decisions by themselves, by the agent themselves. So, but in reality, actually, we are still at the very beginning stage of the agentic AI. So reaching higher agency requires not just the bad technologies, but also maybe, as you know, some governance, maybe some trust, and some organization readiness. We will dive deep into that topic later. So although we are still in the very early stage of agentic AI, that has inversion of future world powered by AI agent. I would like to recommend this Sequoia Capital's keynote address at AI Ascent 2025 in San Francisco, so which is also referenced here. So Sequoia Capital predicts that future AI system will go beyond the current tool-like attributes and evolve into autonomously operating intelligent agents. So these intelligent agents will have capability for reasoning, for planning, for collaboration, and high autonomous operation. So the most striking aspect of the Sequoia Capital's prediction on the right is their vision for the 2030s agent economy. It will operate like a global neural network, so composed of numerous agent operations and forming an interconnected network. So as illustrated on the right. So put simply, if in the future, if the AI agent you designed adopted by the majority people, for example, in Hong Kong, so you could maybe you make enough money to buy a house in Hong Kong, right? But and if the AI agent you designed are adopted by most people worldwide, then congratulations, you will have the excellent chance to become a very rich man. So I think the right is the forecast of the Sequoia Capital for the 2030s. So it's very important because I think it will make everyone know what we should do, make every developer know what we should do in the future. Okay, Sequoia Capital also have some bold projection in their keynote address. The upcoming emergence of the first one-person unicorn means a company will created and operate by a single individual with a valuation of $1 billion US. So this will shift in labor structure has given rise to an entire new organization models. It means a business that can be run by a single person while he or she can do or perform all the functional capabilities and the skill of the complete startup. So additionally, if you look close to the right for the stochastic mindset, which is my favorite here, so the emerging world of AI agent requires to adopt an entire different way of thinking. So I know when we work with large language models, many developers they complain that the output are not very accurate or fail to meet our human being expectations, right? So when facing these frustrations, I would encourage you to consider a completely different perspective. Perhaps it's our way to connect with large language models or connect with AIs, lead to adjustment. So this is why in 2025, forward-thinking AI IDE like Kiro, KIRO, so featured crucial capabilities, which is spec-driven development. So this is another topic. I'm not going to dive deep into it because my time is limited. But however, I hope you to understand this. To succeed in the new era of agentic AI, you must prepare mentally in areas you may not well considered, not only in the technology, but also in some maybe will cause some changes in the organizations and future organization structure and your mental frameworks as well. Okay, so in 2025, we see that much of the foundational structure for the future world of agentic AI is already under construction. For example, if we communication protocols. So during the development of internet, the TCP/IP protocol laid the foundation for network interconnections. So similarly, in the emerging of the agentic AI agents also require interoperabilities. So both with their own tools and also they want to connect with other AI agents as well. So some emerging standards such as MCP and A2A are addressing these challenges. So Here I am not going to dive deep into MCP and A2A, but I want to address what I want to focus is now AWS is actively participate in the Strands communities for both MCP and A2A projects to contribute Amazon's decades of experience in distributing systems and to enhance these future protocols. So this is the complete AWS Agentic AI portfolios comprised of a comprehensive architecture with some supporting services. So from the bottom to the top, you will see these services are organized into 3 layers: infra layers, the AI and the agent developer, software layers, and the application layers. And each layer contains more specific service categories. And today we will focus on the AI and agent development, software and services, and for the SDKs for agents parts, Nova Act and the Strands agents. And Jackie will dive deep into more detail or more scenarios into these SDKs for agents part as well. Yes, we have discussed extensively for the future of agentic AI. So next, I will showcase practical agentic AI applications that automatically retrieve local weather information in Hong Kong. But I think since this, you can very easily, maybe you just need to change the URL. You can make these agentic AI applications easy to use in your country as well. So here's the practical AI agent scenarios demonstrate the local weather application development using the MCP protocol, Amazon Nova Act, and the Hong Kong Observatory website. Let's play the video first. Yes. Yeah, in this video demonstration, we simply provided our agent built with Amazon Nova Act with a special website URL. Then we just directly interact with it using natural language. English, you can use in Spanish or Chinese as well, such as what's the current weather in Hong Kong. So next, we will observe that the amazement as the agent can begin to function like a human being, a verb scraping engineer. So it autonomously located weather information from the Hong Kong website and saved a screenshot file in my computer for verification. Yes, the screenshot here. So if you are a verb scraping engineer, this video might be somewhat shocking, because whether you embrace it or not, the era of agentic AI has arrived. So you may want to prepare for your future, and AWS services like the Amazon Nova Act and later the Strands agents and the agent call. We announced more of the agent call features in the keynote yesterday, so may help you in the huge transition. Okay, so you may want to know the detail about how to implement the AI agent using Amazon Nova Act. It's straightforward. The left screenshot shows the Run Nova Act forecast functions, which guide the Amazon Nova Act on which specific verb pages to capture and what actions to perform. And notably, we directly use the natural language to assign, like the read and extract the complete 9 days weather forecast information visible on this page. And we provided the URL, which is with the Hong Kong Observatory website with the starting page. And on the right screenshot demonstrates a typical MCP call featuring the market MCP tool, decorator, and the process of running Nova Act in separate thread. You may notice that the function function here is the same like the on the right. We just run Nova Act forecast. Yes, if you are interested in the detail about how we implement the code repo is on the right side. Yeah. So if you are curious about the technical details about how we implemented this AI agent, you can read the 2 technical blog posts we written specifically on this topic. And the first part of the post primarily introduce how to independently, so just design the AI agent application using Amazon Nova Act. And the second part demonstrate how to implement an AI agent with MCP and Amazon Nova Act. And if you want to do some using some outside source, you need some maybe your own data. So you want to build them together, that you can refer to the part 2 or to the second blog post. You can scan the QR code on the right to access detail. Okay, so in the previous example, we demonstrate how to rapidly build an AI agent using Nova Act. However, I understand many of the developers, they won't stop there. They have even great ambitions, right? Some developers in Hong Kong and China, they told me they want to build their own agentic AI applications from scratch, and they want to maintain complete source code level control. So they want to control their every line of their code. So in such cases, open source Strands agents can help you to achieve this goal that I will discuss later. If you, like me, and have spoken with many pioneer developers of agentic AI, you will share my insight into the numerous challenges here when the developers want to build their own custom agent at this moment. So on the input side left, we need connectors that enable agents to interact with diverse enterprise systems. So that's why where the tools and MCP come in. So the orchestrator access to this input, so the agent isn't just answering questions, but actually executing workflows like maybe booking hotel, maybe updating some information, or maybe trigger some processes. So in the top sections, we need another important component for building customized AI agent systems, memory, including short-term memory and long-term memory. So short-term memory allows the agent to maintain context within a session, and the long-term memory so enable them to learn and improve over time. So on the right side, you have the brain, the large language models, but instead of treat it as a standalone, so sometimes you need to extend it to be more complex frameworks using like the reactor, like the reflection, and a chain of thought. So and these techniques allow the model to plan, reflect, and reasoning step by step. And the bottom section shows we still need to consider additional element. So because every agent lead a persona, so like a set of rules or instructions that define the agent is and how should behave. And this differentiates an HR agent from maybe a DevOps agent or maybe a custom support agent. And Jackie will also discuss some specific implementation of this aspect in detail when you want to do some multi-agent orchestration. So finally, we need to customize all the AI agents to provide the observabilities and guardrails to keep the agent safe debugable and aligned with our goals. So based on all the custom needs outlined here, you may have already realized that building a truly functional AI agent requires substantial works, and maybe potentially over 80% or even 90% of the effort being unrelated to your unique business logic and the processes. So how to make, so you may have questions. So how to make AI agent development more efficient? That is, AWS provides the framework for you. Yeah, this is Strands agents. So what is Strands agent? Strands agent is Amazon's recent contribution to the global open source community. It's an SDK that enables our developers to build AI agents with minimal code. And the framework simplifies development by eliminating complex agent orchestrations instead and help us to leverage the state-of-the-art large language models to handle planning, chain of thought, tool callings, and others. Next, let me show you how to rapidly build complex, real-world agentic AI applications using the open source Strands agent. Yeah, here's the demo. So in the second demonstration, I will showcase the creation of mathematical animation using Malim. So it's a present library designed specifically for high-quality mathematical virtualization, and the Strands agents will process a user prompt and write a precise Malim script and generate a polished animation like this to demonstrate the powerful capabilities. To combine with maybe with Strands agents and some Python libraries, or some open source projects together. And let's dive deep into a detailed analysis of the core implementation code for this demo. It's very straightforward, so I can show here. So the initial code segment imports the agent class from the Strands module and MCP client class for the Strands tools MCP to establish essential component for a system to utilize agent and the message control protocols within the framework. And yes. And the following code segment sets up a connection to a Malim MCP server using stand input and output as the transport mechanism. And the following code, yes. And next, the code establishes a connection for interaction with the Malim MCP server. It retrieves available tools and from the MCP server and using the MCP client and initial the agent with their tools, preparing for the upcoming task, maybe like the chat loop or like that, or if you want to design for more other tasks. Yeah. And finally, it's very simple. It's very important, but it's very simple if you use Strands agents. The code uses the agent to process a natural language prompt, request a Malim animation. The prompt is asked for virtualization of some specific cubic function graph, functions from x equals -3 to x equals 3. And this video, let me play it first. And this video demonstrates the complete process of building agentic AI applications using Strands Agent SDK to perform mathematical virtualization. So in VS Studio, two terminal windows are utilized. The left one is runs MCP server and which connect to the Malim MCP server, while the stdio transport and the right terminal runs MCP client programs, which launches the video generation chat interface. And through this interface, users can input your natural language command, like, for example, create a Malim scene that draw cubic functions from maybe X ranges in 9 seconds. And after submission, the right terminal will show the agent process the natural language request. And interesting, yes, when I develop this is you see that there is detecting some issues, some combination issues in my local environment. The agent intelligently created a simplified version to complete the task, to demonstrate its adaptive problem-solving capabilities. And the agent already successfully completed the task and provided the output summaries. And the final MP4 video file generated by the AI agent is here. Yes. So now it's easy, very easy to design educational videos now, right? You just need to use some natural language as an input, and the agent can help you with this. Yeah, I want to introduce this because I think it's the future. It's of the educational AI agent in the future. It's very simple because it's only, I designed this program just maybe in 30 minutes. So maybe you can use 3 days or 1 week to make a real enterprise level AI agent. Yeah. Okay. So if you are this complete a whole process of building a agentic AI application for this. So if you are interested in this case, you can scan the QR code here. Left is to rewatch the video, and right is to access the complete demo code for these examples. Yes, and this concludes my presentation for today, and thank you all for listening. Next, I will hand over and the time over to Jackie. Thank you.
Thank you, Hao-Wen. Thank you. So I hope you enjoyed so far. So thanks, Hao-Wen, introducing about Nova X and also about the Strands agents. So first, I'll do a quick survey. If you are a developer, may I raise your hands, please? Sorry. Okay, so how much you use the VS Code slide in the code? Okay, few of them, that's great. So how many of you have already written the agent by yourself? Okay, good, still a few of them. So as to this part, so I could introduce myself. So this is Jackie. So I'm also come from Hong Kong, and I'm a solutions architect, mainly serve the financial service industries. So, and in the coming almost 25 or half an hour, I will talk about multi-agent corporations. As we are developer, right? So I'm also a developer. So people knows nowadays you can have the monolithic, or you also have the containerized microservices. So why multi-agent? The concept is very similar. So for an agent, you can write lots of actions, tools. You can write a huge monolithic agents. But why multi-agent? First, specialization. Right? If you have a specialized agent, so it will work in the specific domains, so it increases the precision, and so that you can have more precise answers. And all combine those specialized agents, you can achieve the superior outcome. Scalability. So because you have those agents and those sub-agents, so during the work life, you can add or remove the agents without impacting the whole systems. So this is how it can scalable. Maintainability. So just as a quick survey, most of them are developers here. So the question is very simple. If you debug 100-line code and another debug 10,000 lines of code, the difficulty is very, very different, right? So with the small agent, and then it's easier to control, to monitoring, to debug, test all the things. Finally, about cost. So as AWS, even in the yesterday Matt Garman, our CEO keynotes, right? Choice matters because you have the model. Typically, we see the model has 3 different scenarios, right? 1 is about sparseness, the reasoning capacity. 2 is about the speed, how fast can respond. The third one is about the cost, right? How cost efficient it is. So if you use the multi-agent, which means for one specific agent, you can choose you can match your task complexity with the right model, right? It can be fast, can be very performance, can be very cost efficient. And in short, I will think the single agent like a specialist skilled solo work, while the multi-agent system is like a well-coordinated team. As I worked in hedge fund before, the monolithic as agent is like a trader, like manage the portfolio all by himself. But multi-agent is like a team, right? You can have the analysts do the market research. You can have the quants doing the modeling. You can have the trades, extra trades. You can have the risk manager, manage the whole portfolio risk. You can have the IT, maintain the underlying infrastructure. So when they combine together, they can achieve the superior performance. And in this way, but there is a condition here is they can work together, right? So how can they work together? The patterns. So Strands agents can support multi-agent collaboration patterns, right? Agents as tools, one graph, workflow. So, and in the coming session, I will talk about those patterns one by one. And first, I will introduce what they is, and then I will use real-life example to showcase how the pattern can help you. Let's start with agent code. For the agent codes, you always have a so-called orchestrator agents. So which will receive the user requirements, understand the intent, and then it will call the specialized agent to perform the specific task. Take this as an example. Here we have the orchestrated agents. When the user sends the requirements, he wants to travel around, right? So for example, if I travel to Las Vegas, by the way, this is my first time here. I mean, I'm very honored to share the session with you. So first, the orchestrator agents will receive the requirements and then he pass to the research agents. It will search, okay, where you can play, like the antelope, canyon, right, all the things. And then it will go pass to the product recommendation assistants. So which means the input of the agents, orchestrator agents will make it the output of the research assistants, the orchestrator agents will make it as input to the next agents. And okay, that's the theory. Now, like I will make a real-life example. In the quantitative hedge fund, nowadays, so the quantitative methodology is very important, especially for those quant researchers. They need to verify their trading idea very fast. So when they fail fast, that means they can find the right trading strategy faster. So yeah, for example, they say, okay, it's a moving average crossover, it's a good trading strategy. You may have different ideas, right? So how the Agentic AI help them? And thanks to I come from Hong Kong and I make this demo with my Hong Kong colleague Charlie Chu. Yeah, so here is the simple input. You can input like the stock that you are interested, like the Amazon, okay, backtest window. So the backtest, which means you use the historical market data to verify your ideas. And then you can get some metrics like the profit and the loss, like the Sharpe ratio, so which means how much risk you take and how much profit you get. And then you can also get a buy condition and sell condition when you want to buy the stock or when you want to sell the stock. And then you can run the backtest. And in our sample, it will give the backtest results, okay, how much you make, and as well, it will give you suggestions, okay, for your trading strategies, whether it's good or not, how to improve the trading strategy, what's the risk behind and any alert. So that's the simple input and output. So you may understand what's the behind this stuff, right? I think developers or architects, you like the architecture diagrams. So here we got the orchestration agents here, and which we will call different tools and agents. So here we got two tools, which is market data tools, another one is backtest tools. And we also got two agents here, so strategy generation agents and results summary agents. And the orchestrator agents, the quant research agents is orchestrator agents. We'll call the sub-agents. In the coming slides, I will focus the three components here. So first, I will show you how to use agent called gateway to build the tools, and then it can be used in the agents. And second one, I will show you the agent called runtime, how to host the strategy generation agents and make the agents as a tool, which will be used by the quant research agents. Let's start with the tools. Amazon SageMaker agent called Gateway. So it provides an easy and secure way for developers to build tools for agents. So you can encapsulate the API or Lambda functions or your existing services into MCP compatible tools. Here, I will use the Lambda function as a backend gateway target. So I store the historical market data in the S3 table, and then this is the function. I will define the catalog. After I log in the catalog, I can start to search the market data I will use in the gateway. After I define the lambda function, I will make the lambda function as the target of the gateway. Okay, so first, I will create a gateway first. Okay, it's very simple with the agent call start toolkit. So agent call gateway create MCP gateway. You give the name, and then in the console you will find the gateway is created. After the gateway is created, you will also notice that inbound identity here, which is a cognito by default, so that when your agent's orchestrator try to call this tool, you need to authenticate so you can get a secure environment. And then as a tool, when we write the agent, we always know you should define a clear input and output of the lambda functions. That's why here I see the name is get market data. Okay, and then in future, when the agent, quant research agent try to call this tool, it will trigger the tool get market data, and you also get the input parameters here. Okay, now I have the gateway ready there, so I will make the gateway a tool to the quant research agents. First, as just mentioned, like you can call the tool calculator, right, to make it a tool. And then you can give the doc string, okay, to define what it is, what's the argument, what's the return. And then you, as mentioned, the gateway will use the cognito by default to do the authentication. And then I will, after the cognito authentication, I will call the gateway, use the HTTPX client, and then I am able to get historical market data to do my back testing. That's about the gateway. After we define the market data tools, and then we will define the strategy generation agents. And for our agents, we will deploy to agent call runtime. So agent call runtime provides a secure and fast way and specialized tools to host your agents. Here I define definitely from the Strands, I import the agent, and then I define the instruction. So it's a trading strategy code generator. I use a backtrader framework. So please generate the code for me. Okay, just give me the Python code because this code will be executed later. And then I define, give the name, give the system prompt, give the model to use. And by the way, you can notice that in the strategy generation agents, I use the Cloud Sonnet, so to leverage its coding capacity, right? And later you will find for another agents, I use Nova model, so which is good in summarization. So this is also the benefits I just talked at the very beginning, right? You can use different language model for different sub-agents. And once I have it, how I to deploy the agent to the runtime? So first, I will from the Bedrock agent call import the Bedrock agent call apps. So after I import the apps, what you need is you give the app.entry points, so to specify once the agent is triggered, where it will be triggered, and then I app.run. Okay, by default, it will listen to port 8080. And once the code is ready, I will deploy it to agent call runtime. It's quite simple actually, right? For the agent call runtime, you can just use agent call config to specify the files and also the requirement files, right? You can have the dependency, a lot of dependencies, so that agent call runtime will install for you and build the container. And then agent call launch. So after agent call launch, you will get the runtime agents in your console, and then you can also check the status, agent call status to check it. So this is how quickly that you can deploy to the agent call, right? So someone will ask you, okay, I do not use Python, I use Java, or for example, right? You can build your own container, right? So just to comply to the agent call runtime protocol, you can have your own, bring your own container to deploy to the agent call runtime. And after that, I will make the agent as a tool. Similarly, so I use the Strands at tool calculator and then generate trading strategies. And I specify the arguments. So please notice here, the input, I'm expecting a JSON file. So you see the name, the buy condition, sell condition, which I just mentioned at the very beginning, right? So this is the input. And then here I use the agent called runtime to invoke the agent called runtimes. So this is how I make the agents as tools. So after you define the two tools, market data tool, you define the strategy generation agents, you define run backtest tools, you define the result summary agents. Now come to the quant research agent, which is the orchestrator agents. It's quite simple. From Strands, I will import agents. You give the sys prompt, right? So for a quant trading strategist, you will like to get historical market data, generate a strategy, run the strategy code, analyze the results. So basically, that's the prompt means. I would like to focus on the tools here because this pattern, remember, right, is the agent as a tool. So here you can see I got the 4 tools: fetch the market data, generate the strategy, run backtest, and create the result summaries. So and if there is something wrong here, the orchestrator, the quant research agents will rerun the general code. So let's see a quick demo. Yeah. So if you have a look at this, you will find that I use the kilo CLI to run the commands. So it's perfect for my debugging because when you run it, the kilo already know the output, and then it will help you debug much faster. Okay, I asked the kilo CLI to run the quant agents for me. So and here it will use the tool execute batch. And then here you can see the JSON file. So I use 10-day period simple moving average, crossover 30-day simple moving average. First, the strategy will try to go the first tools, which is generate trading strategies. And here you can see it first, the agents will make in the JSON input, right? Remember, right? I defined the input as a JSON file, so you can see the JSON formats. And then it's perfectly generate such the crossover strategy for me. So in the Python file, you can see how it process, how generate the trading signals. Okay, it's finished around 6 seconds. After I generate the code, the agent call the fetch market data while the gateway. And here you can see the HTTP request to the gateway here. So the symbol is Amazon, right? Which is I defined at the very beginning. And then, because I defined 1 year, so you can see around 200 data points retrieved from the gateways. And the third step, it will run the actual backtest itself. You can see here, you can get the sample data that I will use in the backtest. And then, because I use the backtrader framework, so Cerebral Engine. Cerebral Engine is the core components about the backtrader framework. And then here, you can also say I need to feed the market data into the Cerebral so that you know the market data, and then it will try to backtest the strategy. And the output here, you can say, that's the initial value, and then, what's the profit you get, and what's the total return, and finally, it will try to create the result summary, and what it is, and how it needs to be improved. So here I also use the agent called memory here. So because I saved the backtest result in the agent called memory. So and in the third step, I will just fetch it from the memory. So this is how you process it. And here, definitely for different quants, they may have different intention. Like here, I give the summary, I give it the recommendations, I give the alerts, and also the key concerns, how I can improve my trading strategies. So if you are interested, so you can scan the live demo here, so to verify, to create your own strategy. So definitely, this is just for information. This does not constitute any investment advice. So please consult with a qualified financial analyst. So let's about the agents as tools. Now, the second one I want to discuss is about swarm. Now, the swarm architecture is a fundamental different patterns. In the agents tool, you can see the orchestrator agents. While in the swarm pattern, there's no single boss. The agents communicate with each other and collaborate dynamically to solve the problem. The swarm maintains a shared context so that all agents can access. So it's about who is in the swarm system, what's the other agents, the input and output, what's historical interactions. let's use this one as example, right? You got the research agent, creative agent, critical agent, summarize agent. So I want to write a blog or all the things. So here you can first I define the 4 different agents here, right? So one to do the research, and one is to be creative, to create something. And then the third one is how to challenge what you already created. And finally, I will do the summarize to give the final results. And then from the Strands store multi-agent, I import the Swarm class. And the Swarm class, I give the 4 agents, and I definitely define the max handoff, max interactions, so that it won't run infinitely. And also, I do not want the 2 agents to communicate with each other, the ping pong, that loop. So I have the repetitive handoff detection window, and also the repetitive handoff mean unique agents, which means in the last 8 handoff, at least 3 agents should be involved. So let's see how it works. Yeah, okay. So the task is, please create a blog post, explain Agentic AI, and then create a summary for a social media blog. So first, it will create a blog, and then a social media post. Let's see how it works. First, once the Swarm receives the request, it will first call the research agent, because it knows I need to find what information I can gather, right? So these are facts. You need the research agents. After the research agent found the stuff, and then it will try to call the creative agents, right? Because it needs to create an engaging blog. And it knows, okay, after I create a blog, I will hand off to the summarizer agents to create the social media post. And the interesting happens here. In the summarizer agents, it definitely will try to create a post. However, it found that in order to create a summary, I see the general structure of the blog post from the creative agent's descriptions, but I need more details to create an effective social media summary. So this is the reasoning from the summarizer agent. In this way, it won't hand over to the staff. It will hand over back to the creative agents so that it will fill the content. And now the creative agent received it, will say, okay, now let me create a comprehensive blog post and then hand off to the summarizer agent again. And finally, the summarizer agent is able to create the blog and also the post. And here you can see, okay, there are total 5 interactions. And also for the Strands agent framework, we also have the tools, right? So from Strands tools, I can import a Swarm tool. And when I define the agents, I have import a tool as a Swarm. And then in the results, okay, use a Swarm of 3 agents to analyze or to do the things. And these agents will spin off 3 agents to do the task. So this is use a Swarm as a tool. Now I discuss about the agents tool, Swarm patterns. The third one I will discuss is about graph. In graph pattern, you can define the agent relationship as a graph network. So each agent is a node, and the edge between them define the relationship, define the information flow, how they can communicate with each other. So the key advantage of the graph pattern is predictability and also the control, right? In this graph, for example, the economic department can only communicate with the market research and the financial analyst. And it is not allowed to communicate with social analyst or technical analyst. So this is how you have the predictability and full control about the information flow. I would like to use an example, the Agentic Fund Manager developed by our Korean colleague, Kang-Wan Lee. Okay, so Kang-Wan developed this Agentic AI fund manager here. So maybe it sounds complicated. I will use 2 specific agents here to demonstrate the graph here. So first, it will about the portfolio architect, and then about fund manager. So similarly, always I define the agent first. Okay, so this one, I will define how it will construct a portfolio, okay, to fulfill the customer requirements. So here you can get a prompt, define the agents. I know you should be very familiar with this now. And then in the graph, we have the nodes, right? So I will define the portfolio nodes. In the portfolio nodes, which will trigger the age. It's also deployed to the agent call, right? So it will call the agent with streaming. And finally, let's talk about the fund manager itself. I use this example to showcase that Strands Agents SDK, it can work with very generic other open source or popular agentic framework. So here you can see I use the Strands agent to work with the long graph. Right? I know you work with the long chain and also other popular frameworks. Right? For this one, I use the long chain here, and you can define, okay, from the graph, long graph, the graph, I import the state graph. In the state graph, I define the workflow here. So I add the nodes of financial, add nodes of the portfolio, which I define, and also add nodes of the risk. And then after I add nodes, I add the edge. Okay, so from the financial to the portfolio, from the portfolio to risk, and the risk is the end nodes. So this is how I use the graph to define the nodes and then the edge. So you can have a full control. So if you are interested, you can have the demo and also the code repo developed by Kwang-Wan Lee. Okay, so agent as tool, swarm, graph. The last one is workflow. I think workflow is quite straightforward for us, right? So you can have a very well-defined sequence or patterns. Here you can say, okay, I have the research agents and then analysis agents and then finally the report agents. So here you can say when I define from the Strands tools, I import the workflow, and in the workflow I define several tasks, and in the task I define the dependency. Here, so for example, the task ID trend and analysis will depend on the data extraction, and then the task report generation will depend on the trend analysis. So this is how you define the workflow. You can also have the priority here, so that if you have multiple sub-agents, they can run parallelly, and the priority will determine which run first. So we talk about those 4 different patterns, right? So agent as tool and all the force. In this coming 5 minutes, so I will give some sample use case so that you can apply in your own company after you leave Las Vegas. First, agent as tools. So, for example, customer service chatbot can be a good example, right? So when you receive the customer request, the orchestrator agents can call your technical account manager, can call your billing agents, that can call your summarizer agents, and then provide output to your customers. And then the swarm patterns, right? For the swarm patterns, so those individual agents so interact locally, right, and then to produce a complex emergent behavior without centralized control. So here, for example, for the multidisciplinary incident response, right? If you have any instance, you may have different problems, right? First, you may think it's like a networking issue, right? And then you pass a network agent, and then the network agent will check itself and find, no, it's not my problem. It can be the database problem, and then it passes to the database agents, and the database agent will check, okay, and then solve it, right? So here you can say those agents, they dynamically communicate with each other. And the graph. So as I just mentioned, the graph enables complex communication while maintain the well-controlled information flow. You can define which agent can communicate with which agent. So like the data validation with error path, right? So you can control, okay, first you will have an agent to determine, okay, which has a problem, whether it has no errors, and then it's passed to different agents. One can be the data validation without error. Another can be the data agent with error path, right? So this is how you clearly define the graph, network graph, right? And finally, it's about the workflow, right? So the workflow is a perfect match. Right? I mean, if you have a complex and a repeatable process, and you want to encapture it in a single, reliable, and reusable tools, right? And so, for example, for the automated data pipelines, right? So you have if you do have a data engineer here, right? So you have the data extraction, you have the data pipe, data ETL, right? You will do the data transform, right? And then you will load data into your data warehouse or all the things, and then build a pipeline. So this is a perfect match for the workflow. So that's the 4 pattern about the Strands agents that you can leverage, and now let's quick recap what we discussed. So as Howard just introduced about our AWS Agentic AI portfolio, I believe you see this diagram lots of times during our reInvent. So again, I would like to welcome you to reInvent, and I hope you enjoyed the session. So today we focus on NovaX and the Strands agents. And also we do a quick demo here, right? So we demo the weather AI application, the manual video generation, and also I and my Hong Kong colleague Charlie Chu developed the agentic practice testing, and my Korean colleague Kwang Wan Lee developed the agentic AI fund managers. So please feel free to take a picture here, and later you can check the code repo and check the demo itself. So and finally, we would like to have your feedback here. So please open your apps, and so give us your feedback, and your feedback is important for us to improve. And also, I hope you enjoy the rest of the event. Thanks for coming, and thank you for coming to our session. Have a great day.